Hey folks, welcome to Learn the Algorithm with me together. Today we will take a look at 703, the kth largest elements in a string. And what is this problem is talking about? We'll be designing a class to find the kth largest element in a string. And we have to note that it is the kth largest element in a sorted order. Not the case distinct elements. So what will be look like? The class will be first initialized with a case number and also an integer arrays numbers, and then we will have a function to continue to add number into this string, and then we will return the element represent the kth largest number in a string. So probably we'll have these examples to understand it much better. For example, the input is the kth largest. It means that we are starting to initialize this array, and we'll have the kth is the 3 and the array is 4, 5, 8, 2. So this will be the array. And now since the k is 3, so which is the k? Like, of course, first we will sort it. It will this is the original numbers, and then after we sort it, it should be look like this. So because we want to get the kth largest, and it will be sorted like descending. For example, 8, 5, 4, 2, right? And the kth is 3. It means that now the number 3 is this one. So till now the kth is 4, but of course, since we just initialize it, we don't have to return anything. But then we can start to add the numbers, like the next number is 3. So what should be the 3 will be inserted? It should be here, right? And now we will return the kth value is still the 4th, because the k is 3. And then we will add the number 5. 5 is greater than 4, so this number will be added before the 4. And now we will return the 5 because it is in the 5th place. I mean in the 3rd place. K is 3, right? So it is in the 3rd place. And then we will add 10. 10 is greater than 8, so it will be ahead of the 8. And now the third number is 5. We can return 5. And then we can add the number 9. So the third number will be 8. We will return 8. And the last number we can add is 4. 4 is we can add it here. And it doesn't impact the third greatest number, so we continue to return 8. So this is how idea we what we can do. Like the users can continue to edit the numbers, but we always return the third largest number in this string, right? Okay, so what I have done before is I have to keep this sorted array always be sorted. So when the new number is added in, it always be there, right? So it means that this is like a box to collect all the numbers, and this box will be sorted this number automatically. Like for example, like when we're adding a new number, it will start it to put it in the right position. And of course, if we initialize these numbers, it is not initialized it is not sorted at first. Every time when we call this function, we just started to sort these collections of numbers. It will cause us like on log n time. The usually the sorting algorithm will be on log n, and we start sorting it, and then we use an index to point to the third place, cause as constant time. So the original idea is like, for example, like we have a collection of numbers which is not sorted. So every time one function call, we sort it. Function call, we start to sort this collection, cause us like O n log n, O log n time complexity, and then we can use an index to get the kth largest number, which usually, like if you use an array or array list, usually just constant time. So total time complexity will be like O n log n, right? This is efficient, and then we have to improve. Like for example, if when we are initialize this arrays, we start to use this box, start to do the collection, right? We can have a box and start to collect, we have this box to collect all these numbers and start to do the sorting. And because we are just care about the kth largest number, so it means that we don't need to care about like if the rest of the numbers are where the positions are. For example, let's step back, right? Like for example, at this initialized sort is, it will be like A5 4 2, and we always point it to 4, right? Do we need to care about the 2? No, because no matter what numbers added, we don't care about it anymore. It means that we can probably just ignore it, right? Like then we added 3, it will just going backward, and like for this, we add 3 here, it just go backward. We don't care about the 2 anymore. But when you sorted it, and here we can come up with what kind of this box can help us to sort it. We can use probably a PriorityQueue, right? What is the characteristic of a PriorityQueue? A PriorityQueue is like uh, we can maintain a max heap or a min heap. And a max heap is like we always like have the numbers here. For example, this one will be if it is 8, when we add this number here, and then when we how about this, like when we go through the original list, when we add the 4 here, and then we add 5 is like for example is greater than 4, it will pop up to before the 4, and the 4 will be go go backward. And then we add another number, 8. 8 is greater than 5, it will go to the ahead of this queue and then move the other 2 back. So this is the max heap, a priority queue. It will always keep the largest number in front of all the other numbers. So every time when we pop up a number, if the worst case is it always go to the top of this queue, because priority queue is the structure is more like a tree or something, and the time complexity will be the worst case is the O log k, and k is the probably we don't use k here, it will be confused with the k's largest. We can use the height, is the height of the tree. So the worst case O log h. So every time I just like keep the numbers, the largest one is go to the head of the queue, and then we add 2 here, and 2 is the smallest one. We don't need to pop it up to the front of the queue, so just put it here. And okay, this is the max heap. But now, because we don't need to care about the rest of the numbers, so it means that we can just make a fixed size of this priority queue, so that we can save some space. We don't need to always keep all the numbers here, right? And to waste of our memories or space or something else. So then we need to pop out this new number, the smallest number, because we always want the kth number, and the kth is the size of the should be the size of this priority queue, like the 4th here. So we need to pop out 2. Alright, so what I mentioned that it probably use a max heap, that's incorrect now, because we want to pull out the smallest numbers, and max heaps is always keep the maximum number in front of it, and then get the maximum number or pull out the maximum number. And now it should be pull out 8, but this doesn't what I want. I want to pull out the smallest one. So it means that I need to maintain a min heap here. So let's reorder this, all the numbers. So we always put the smallest numbers in front of this queue. And now we can say we wanted to have a min heap. And we always keep the smallest one, so that we can like pull out the smallest one, or make the pointers always point to the smallest one. The smallest one is if the size of the queue is just a k, it means that this is the number we want, right? Because the size, like the size of the 3, always the first number is also the kth number. And now when we add 2, we want to pull it out because the pointer is pointed to the smallest one, so it will be get out of it. And now the pointer will continue to point to the smallest numbers here. This is what we want. So now it means that the main heap is fixed side, what we want to do. And here we say and now if we continue to add from the example, we add number 3, right? 3 is smaller than 4. We can continue to, when we add here, the point is pointing it, but we can pull out it later because we have to make the size continue to be k, so that it will always be the kth largest. And then we add 5. Add 5 here, and because it's greater than 4, and now we can pop out the 4. We don't need that anymore. And now the pointers can be pointed to the 5. And then we can add 10, and 10 is greater than any others. Yeah, so 10 will be at the end of this queue, and then we will pop up the smallest one. We don't need that anymore, so the smaller it will be 5 again. So this is the idea of the min heap. It's always to keep the smallest numbers in at the head of the queue. Like if we add some smallest numbers here, like 3, it will continue to pop up to the head of the 8. And then if the size is greater than the fixed size we want to have is k, we have to pop it out because we don't need it. So the whole idea is when we initialize this kth largest number, we can start to initialize this queue. Let's see. Initialize the objects. We can first to create a queue, or we can say min heap. And then what we do is go through or traverse the array and put all the numbers, or we can say put each of the numbers into, let's say when we traverse the array, when we are looping it, we will start to put the number into min heap, right? When we are putting in it, we always consider if the size of the min heap is like greater than k, right? Because we want a fixed size. If yes, then just pull out a number from the main heap, like so that we can always keep it as a fixed size. This is what we initialize doing this. And then we start to have the function call, right? We'll have like a new number. So when putting in a new number, of course we will put the number to the main heap. When we put in the main heap, we also check if the size of the main heap is greater than k. If it is, then pull out a number from the main heap. So now let's do some analysis. For the space complexity, because we have to maintain a main heap, but of course it's a fixed size, so the space complexity will be OK. The k is the kth number, because we always like maintain the k numbers in the main heap. And then when we are initialize this object, because we have to go through the numbers, it will cause us like the O(n) time complexity. And then when we put this number into the k, we care about the height. So for probably, no, this is not good. All right, and yeah, for this is about the space. Space is OK, right? For time, because we traverse the whole array, so it'll be O(n). And also, when we put the number, it will pop up. The worst case is we care about the height of the tree, and yeah, that's probably we can ignore it. It won't be too much for a PriorityQueue. And as I say, it's the height of the tree, and probably I would think is because the size is k, and the worst case is probably O log k. And yeah, so mostly the time complexity won't be larger than, the time complexity won't be greater than O(n). And for this function, it's also like when we are adding a new number into the PriorityQueue, the worst case is the O(n) log k. And then since the pointers, if the size of it is greater than 8, we need to pop our number. We will use like constant time. So the time complexity for this one will be O(n) log k as well, because yeah, the rest is just a constant time, doesn't cost much. But of course, now here's a corner case. What about there are not enough numbers, like not enough kth numbers? What we'll do? Let's see. It's guaranteed that there will be always at least k numbers. All right, so it will be guaranteed that. That would be great. This is the idea. So we don't need to care about if there's not enough numbers. Now let's coding right now. So first we will say initialize the object, and because the main heap will be used in both of the place, we will be use a global variable private, like PriorityQueue what we'll store is just integer, and it is a min heap. And here we will say, new we have the min heap now, and we start to traverse the array, and we can see that right now we just like put a new number here and to check the size of the min heap, so we can probably like make a function to doing this. And I believe in the object-oriented design, this is one of the principle. It will be, I don't quite remember, but I hope next time I can remember what the principle it is. And we will have a function, because it's only be used in this class. We can have a private function void, because we don't need to return anything, just to put a new number and keep the size of the min heap. And we can say maintain the heap, right? And we can have the input is the number here. Okay, cool. And then now we just put the number, and if the min heap is greater than k, of course now we need k. And do we need to make it as a global number? Yeah, because both of the function need this k, and we can say private final, because we cannot change this number in the future. Make it as a final int. Probably we don't need to say k, we can say size of the min heap, size of the heap, so that we can know what we are doing, what we are keeping, right? So the size of the heap is always k, right? And now we have to say, now if the min heap size is great, then is it will be confused, or so if the current size is greater than the size we decide, we have to pop up the last number. This is what we're gonna do. And now, okay, we can start to traverse the numbers. We can just call this function here number. It will help us to do. And so does this one. We can just call this function. Add the number. And now what we return is just the first number, means the pick function. So this is the design, and I believe, and let's run it. Cool. Now it passed. Now let's submit it. Cool. So it passed all the cases. And I hope you can learn something from what is the PriorityQueue, and we can know that PriorityQueue usually to help us to solve some problems like the k's largest number or k's smallest number, like the top k problem. And thanks for watching.